Hello everyone, welcome back to my channel. In this video, we will discuss about SDE sheet problem that's name is toggle bits given ranges. Okay, you have given a non-negative integer n and two values l and r. Okay, so what you will do, you will simply toggle the bit within a given ranges, within a given ranges l to r. Okay, the which means of that if the bit is 0, so you have to convert the 1, and if the bit is 1, so you have to be convert a 0, and after that you should have to be a print n after the modification of the bit, after the modification of the bit. I hope you all might be clear. So so let us discuss with that example. This is a number n which is having a 70. Okay, and you have a two number, a two uh, value which is L and R. These are the ranges. These are the ranges which is to get that value. To how to toggle within a ranges. To toggle within a ranges. Okay. So so now the binary representation of the 17 is 1 0 0 0 1. This is the binary representation of the bit. Okay. So the L, which is 2, the representation of this L is this, and R is 3, which is representation of this bit. I hope you all are understood very well. Okay. Now, after the modification of this 2 bit, you have to be convert a 1 and 1. So your modification of this bit, so the number will be equal to that in this form. So this value is equal to that 23. Okay, now how we can solve it? So what would be your brute force approach for solving this problem? First of all, you have to be a run a for loop from I, which is L minus 1 to R. I hope you all understood. Okay, now what you will do, you will simply you will simply check the bit check the bit of the ith and toggle this bit of, and toggle this bit and update into that number n, update the number into that n. I hope you all understood. This is a 1, this is 1, and okay, so what does it do? So what is doing this operation? So you have a number like 10001. Okay, now what you will do, left shift you will simply left shift of one this one in the ith time. So I is now that I is equal to that 1, because 2 minus 1 is equal to 1. Okay, so 1 is representing that 1 and 0. So one time I will shift the 1. Because of that, this is a 0, this is a 1. So one time the bit is will be 1. So bit will be that like in this form, and after that XOR operation, XOR operation with this current value of n, with this current value of n. So your bit will be toggle that like 1 and 0 1, 0 and 1 1, 0 and 0 is equal to that 0. And and now what you will do, you will simply 0 and 0. So 0 0 is equal to that 0 and 1 0 is 1. Because of that, you know very well that XOR operation is that same bit same bit will be given you 0 and different bit will be given a 1. I hope you all understood very well of this XOR property. So now on this first time that I is 1, so you have to be convert the n is equal to that this one. Now again you have to be solve this again, that for loop will be run and increment the for loop by plus 1. So now what you will do, you will simply again 1 0 0 1 and 1 1 and 1. Okay, so what you will do, you will simply increment the I, which is 2. Now I is equal to that 2. So the bit will be a 2 move 2 times. So bit will be representing like this. After that, shifting left side by 2. Okay, so that 1 0 1 1 0 1 1 0 1 0 0 0 and 1 0 is 1. The XOR, after that XOR property, that the final bit is that 1 0 1 1 1. So now again increment that I is equal to that 3, but that I is so so after that false of this condition, you have to be simply return return your number. I hope you all understood very well. So this operation will be a time complexity order of arc time. Okay, this is your time complexity. I hope you all understood very well. So now you can solve, you can optimize this in order to that single complexity. Okay, so how you can solve it? How you can solve it? How you can solve it? You can simply use this formula like num is equal to that shifting the left side, shifting the left side of that rth rth number. Okay, minus 1 and XOR property with that shifting that a left side L minus 1 of this value. Okay, I hope you all are very well. So it is working? How it is working? Now what you will do? You will simply check this bit. Check this bit like 1 0 0 0 1. This is the binary representation of the 17. Okay, how you can solve it? So R is equal to that at 3. So 3. So 1 0 0 0. This is the 3 time the shifting of a 1. Okay, minus 1 minus 1. After that XOR operation, now L minus 1 means of that 2 times means of that once time, because L is given that 2, so 2 minus 1, so one time of this binary of this shifting of the 1 is 1 minus 1. I hope you all are understood very well. So this is value of 8. 8 minus 1 is 7, so the value is 0 1 1 1. Okay, and XOR operation with that sorry of that 1 and 0. Okay, so 1 and 0. After that, this, this is that after that 2 minus 1, because of that this value is representation of the 2, this bit value. So after that 2 minus 1 is 1, so bit representation of this 1 is 1. After that XOR operation with the with this value, XOR operation with this value, so what will be happen? So this is the same bit, so 0. This is the different bit, is 1 1 and 0. So now your final output is equal to that this. Okay, so this having a time complexity is order of 1. I hope this approach will be clear to you. So now how you can solve how you can solve it. So this operation, suppose of the 4. Firstly, we will run a for loop for a brute force approach. Let us understand this. I plus plus, now again that n XOR will be ith time I will be a shifting of this one and return the value of n. I hope you all understood. Let us run of this value. Oh, so my mistake is that I did not declare it int. So I hope you all are understood this mistake, that so the compiling and working, so our output is equal to that expected output. Okay, so this is the brute force approach. So now how you can control of this brute force approach. So now you will simply take a num take a num and and one will be a shifting that rth time rth time. Okay, and minus with the 1. Because of that I want to be get this all the set bit within within a given ranges. And again what I will do, I will simply left bit shifting of that L minus 1 time. L minus 1 time. Okay, then minus 1. So now what we will do, we will simply return num XOR the L. I hope you all understood that this programming approach, this is working fine. So this is a solution of the C++, and here is the solution of a Java. So this is also working very fine. If you have understood this logic, please like my video, please subscribe my channel, please share my video. Thank you so much for watching my video. Thank you.